Hello everyone, welcome back to our channel Begin Engineering. Today our topic is evolutes and involutes. So what is evolute? Evolute is a particular curve associated with another curve through some mathematical way. Okay, and before going to discuss what is evolutes, we need some mathematical terms or items like radius of curvature, center of curvature of the curve. So let us first discuss curvature of a curve. Curvature of a curve. Let us say this is our curve and is a straight line. So let us say this point is A, this point is B, this point is C, this point is D, this is E, and this point is F, and this point is P. Is its PT tangent. Now see from this graph, here P is a variable point on the curve. This P point is a variable point on the curve. So PT is variable tangent. If these P points come here, then tangent would be something like this. If this P point comes here, then tangent will something like this. So we can see that as P moves on the curve, okay, this tangent will turn. This rotation will be higher from B to C than that of within the arc AB. The rotation will be higher in BC than AB. We call bending of curve in the portion BC, this is bending of curve, is greater than that of in the portion AB. Similarly, if we compare this amount of bending in the portion CD, with the amount of bending with the portion EF, we shall see the bending is very less as the point P passes from E to F. It is almost linear, right? So it is natural that we should look for a tool which will measure the bending property of a curve at every point on it. So that's why we coined this term curvature. So curvature is that measure which is defined as the rate of change of angle psi. Let us see another curve. Let us say we have this curve and at point P there is a tangent which makes angle psi with the positive direction of x-axis. This is PT tangent. Let us say this point is A point. This is our origin. This is y-axis, this is x-axis. So curvature is that measure which is defined as the rate of change of angle psi made by the tangent with x-axis with respect to the length of arc of the curve. So mathematically we can say, if for a curve with A as a fixed point, let us say this A is a fixed point, on it AP, this curvature, let us say this curvature AP curvature is S, and psi as the angle made by the tangent of the curvature at P point with positive direction of x axis. So we can say that P is d psi by ds at point P. Okay. So the curvature of a curve is denoted by k, small k, but this definition is very straightforward. It is complicated to find if the equation of the curve is given in Cartesian coordinate system, that is in xy. So let us see some theorem related to this. That is, our first theorem is curvature at every point on a straight line is 0. It is obvious, right? Curvature at every point on a straight line is 0. Why? Because in that case this psi would be constant. So differentiation of constant is 0. This is our theorem 1. Let us say our theorem 2 is the curvature at every point of a circle is constant and equals the reciprocal of the radius of the circle. So let me write it here. The curvature at every point of a circle is constant and equals the reciprocal of the radius of the circle. Okay. So let us see one example. Let us say this gamma be a circle with radius 4. This gamma be a circle with radius 4. Then we can say that at every point of this circle, radius of curvature will be 1 by 4. This is your radius of curvature according to this theorem. Now moving forward to our next topic, which is circle of curvature. Let us see what is circle of curvature. So let me first draw a diagram. Let's say we have a circle. Let's say this is a curve. And this is your tangent. At point P is the center of the circle C. And this is your, let us say this is your gamma curve. So let this gamma be the curve and P be any point on it. So we have constructed a circle such that the circle and this curve have same tangent at point P. So if you notice, this curve has the same tangent and this circle has the same tangent at point P. The circle lies on the same side of the tangent, it is one side, as the curve, and the circle has same curvature as the curve gamma, right? The circle has the same curvature. See, this is the curvature of circle and this is the curvature of the curve. This circle is called circle of curvature of the curve gamma at the point P. Its center C is called center of curvature of gamma at point P. The radius of the circle of curvature at point P is called radius of curvature. So let us say this is the radius of the circle. So this would be the radius of curvature also. So radius of curvature of a curve is denoted by rho. Okay, this is the radius of curvature. Okay, so you can see that circle of curvature and so the center of curvature and radius of curvature will vary as the point P travels on the curve pi gamma curve. Thus, at point P, the curvature of this curve gamma is k. This k is the curvature of the circle, the curvature of the curve, and the curvature of the circle. Curvature of the circle. And according to our last theorem, we know that curvature of circle is 1 by radius of the circle of curvature. So this should be 1 by radius of the circle of curvature. So this is equal to radius of curvature of gamma. Radius of the curvature of gamma. This is 1 by rho. So thus we get k equals to 1 by rho at any point on the curve. So this is the relation between curvature and radius of curvature of the curve. Remember this. Now let's move forward to our next topic, which is what should be the formula of radius of curvature. So formula of radius of curvature, rho. See, if the equation of the curve is given, then let us say y is equal to fx, or let us say x equals to f of y, and this is given in Cartesian coordinate system. In Cartesian coordinate system. So rho would be mod of 1 plus y1 square to the power 3 by 2 by y2, where y2 can never be 0, and rho can be modulus of 1 plus x1 square to the power 3 by 2 by x2, where x2 can never be 0. Here our y1 is first derivative, that is dy by dx, y2 is second derivative, that is d2y by dx2, x1 is first derivative, that is dx by dy, and x2 is second derivative, that is d2x by dy square. Now let us say if r equals to f of theta is a curve function, and this is given in polar coordinate system. This is in polar coordinate system. Then our radius of curvature would be mod of r square plus r1 square to the power 3 by 2 by r square plus 2r1 square minus r2. This would be the formula, where r1 is dr by d theta and r2 is d2r by d theta square. So let us see one example to apply this formula. Let us say find the radius of curvature of the curve x cube plus y cube equals to 3xy at the point 3 by 2, 3 by 2. Okay, so let's see the solution. See, first of all we have to find out first derivative and second derivative, right? So our equation is x cube plus y cube equals to 3xy. So let us first differentiate both the sides with respect to y, with respect to x. So this would be 3x square plus 3y square, and for y it would be dy by dx, and you have to apply u into v rule here, keeping y dx by dx is 1, keeping x for y it would be dy by dx. So if you cancel 3 from both the sides, you will get x square plus y square into dy by dx. That should be y plus x into dy by dx. So our dy by dx would be, if you take this dy by dx in one side and take common, dy by dx would be x square minus y by x minus y square. Now let us find dy by dx at point 3 by 2 comma 3 by 2. So put 3 by 2 in place of x and 3 by 2 in place of y. We will get minus 1. Okay. Now we need second derivative. So differentiate this equation with respect to x again. So d2y by dx2 would be, you have to apply u by v rule here. So v square, keeping v as it is, differentiation of numerator. So this would be 2x minus dy by dx, minus, keeping numerator as it is, differentiation of denominator. So this would be 1 minus 2y into dy by dx. Okay. Now let us find out d2y by dx2 at 3 by 2 comma 3 by 2. So put 3 by 2 in place of x and put 3 by 2 in place of y and put minus 1 in place of dy by dx. You will get d2y by dx2 as minus 32 by 3. So what is the formula of radius of curvature? Because it is given in Cartesian form. So radius of, and we have found out dy by dx. So we have to utilize this formula. 1 plus y1 square to the power 3 by 2 by y2. So our radius of curvature would be 1 plus y1 square to the power 3 by 2 by y2. And if you put all the value, 1 plus y1 square, y1 is minus 1 square is plus 1 to the power 3 by 2 by minus 32 by 3. After calculation, you will get 3 root 2 by 16. So this is the radius of curvature. Now let us see formula for center of curvature. Formula for center of curvature. This is formula of radius of curvature. So let gamma be a curve and p be a point on the curve. Let us say x bar and y bar be the coordinates of the center of curvature of gamma at point P. So you can say x bar, this x bar and y bar is the coordinates of the center of curvature. This is coordinate of center of curvature of gamma at P. So x bar would be the formula is x minus y1 into 1 plus y1 square divided by y2, and y bar would be y plus 1 plus y1 square by y2. And for both of the things, y2 can never be 0 because it is in the denominator. Now y1 is dy by dx and y2 is d2y by dx2 at point P. And you can write this x bar and y bar as x. So x bar is x plus 1 plus x1 square by x2, and y bar is y minus x1 into 1 plus x1 square by x2. here x2 can never be 0. So remember here x1 is dx by dy and x2 is d2x by dy square. You can use any one of the formula. So let us see by one question. Find the center of curvature of the curve 2xy plus x plus y equals to 4 at the point 1 comma 1. So let's see the solution. Our curve is 2xy plus x plus y equals to 4. Now let's differentiate both the sides with respect to x. So it will be twice, you have to apply un to v rule. It will be y plus x into dy by dx. Differentiation of x is 1, differentiation of y is dy by dx. So 1 plus dy by dx is to 0. Now let's simplify. 2y plus 2x into dy by dx plus 1 plus dy by dx, that is 0. If we take common dy by dx, this would be minus of 2y plus 1 by 2x plus 1. So dy by dx at 1 comma 1 is, if you put 1 and 1 in place of x and y, you will get minus 1. Now you can differentiate both sides with respect to x. Okay, let's differentiate this side. It will be easy. So it will be twice dy by dx plus, you have to apply u into v rule. So twice dy by dx, differentiation of x is 1 plus 2x into d2y by dx2 plus differentiation of 1 is 0 and dy by dx differentiation is d2y by dx2 is 0. This implies at 1 comma 1 this equation would be 4 times is 2 plus 2 4 times dy by dx at point 1 comma 1 plus 2 into 1 into d2y by dx2 at point 1 comma 1 plus d2y by dx2 at point 1 comma 1 is 0. And we know dy by dx at 1 comma 1 is minus 1. So this is minus 4. Okay. Now this is 2 plus 1 3. So minus 4 plus 3 into d2y by dx2 at point 1 comma 1 should be 0. So from this we can say d2y by dx2 at point 1 comma 1 is 4 by 3. Okay. Now we know dy by dx at point 1 comma 1, we know d2y by dx2 at point 1 comma 1. Now we can find out center of curvature, that is x bar comma y bar. So what is the formula of x bar? This is x minus y1 into 1 plus y1 square by y2, and y bar is y plus 1 plus y1 square by y2. If you put 1 in place of x and y1 is minus 1, y2 is 4 by 3. This x bar comes out to be 5 by 2. And if you put 1 in place of y and y1 as minus 1 and y2 as 4 by 3, you will get y bar as 5 by 2. So our center of curvature at point 1 comma 1 is 5 by 2 comma 5 by 2. So this is the answer. Now let's see evolute and involute. Evolute and involute. So let gamma be a curve and C x bar y bar be center of curvature of this curve gamma at point P. At point P, the locus of C as the point P travels on the curve gamma is called evolutes. Okay, so we can say the locus of C as the point P travels on the curve gamma is called the evolutes of the curve gamma. In other words, you can say if the curve gamma 1, this is gamma 1, let us say this is any curve, be evolute of gamma, then this gamma is called involute of the curve gamma 1. Okay, this is as simple as that. If gamma 1 is the evolute of the curve gamma, then gamma would be involutes of the curve gamma 1. Now let us see the rules to find evolutes of a curve. Rule to find evolute of a curve. Okay, see, we already know how to find out x bar and y bar, that is center of curvature of the curve, right? We know x bar is x minus y1 into 1 plus y1 square by y2, and y bar as y plus 1 plus y1 square by y2. If you want to use the alternate formula, you can use also. You have to eliminate x and y. Remember, you have to eliminate x and y from these two equations. And the equation of gamma, you will get the equation of evolute. So let us see through one example. Find the equation of the evolute of the parabola y square equals to 4x. So let's see how to find out evolute. So let's see x bar y bar is the center of curvature, is the center of curvature of the parabola at p x comma y, and we know that x bar is this and y bar is this. So let's differentiate this curve and get y1 and y2. So y square equals to 4x. Differentiating both sides with respect to x, we'll get 2y into dy by dx is 4a, or you can say y into dy by dx is 2a. So dy by dx would be 2a by y. So we get our first point, that is y1 is 2a by y. Now again differentiate with respect to x, you will get y2. So d2y by dx square, if you differentiate this, y to the power minus 1, it will, differentiation of y to the power minus 1 is minus 1 by y square. So it would be minus 2a by y square, and differentiation of y is dy by dx. And we know dy by dx is 2a by y. So 2a by y square into 2a by y. It will be minus 4a square by y cube. So this is your y2. So y2 is minus 4a square by y cube. Now let's put in this formula. So our x bar is x minus y1 into 1 plus y1 square by y2. So this would be x minus y1 is 2a by y, 1 plus y1 square, that is 4a square by y square, by y2. y2 is minus 4a square by y cube. So sorry, this division would be up to this. So we'll get x minus, this minus minus would be plus, this is 2a by 2a and 2a, 1 2a will cancel out from this, and this y cube will come out in the numerator and this y will cancel out. So you will get x plus y square by 2a into 1 plus 4a square by y square. So ultimately we get x bar is x plus this is y square by 2a into 1. This y square will cancel out, 2a and 2a will cancel out, you will get 2a. Now similarly we have to find out y. What is y bar? Y bar is y plus 1 plus y1 square by y2. So y bar is y plus 1 plus y1 square by y2. Okay. Now put all the values. This is y plus 1 plus 4a square by y square, and this is y2 is minus 4a square by y cube. Now this minus will come here. So y minus y cube by 4a square multiplied by y square plus 4a square by y square. So this would be y square, this will cancel out. Y minus y by 4a square into y square plus 4a square. This is 4a square. If you multiply this, you will get y minus y cube by 4a square minus y. This 4a square per square will cancel out. And this y and y will cancel out. So ultimately we get y bar is minus y cube by 4a square. So you got x bar, you got y bar. Now what is the method I have told you? You have to eliminate x and y. Okay. So let us say that y square equals to 4x. Let us say this is our equation number 2, this is our equation number 3, and this y square equals to 4x is your equation number 1. This is equation 1. So from this you can say that x is y square by 4a. And let's put this value in this. So x bar would be y square by 4a plus y square by 2a plus 2a. That is 3y square by 4a would be x bar minus 2a. So this y square would be 4a by 3 x bar minus 2a. So this y would be 4a by 3 x bar minus 2a to the power half. So y cube would be 4a by 3 x bar minus 2a to the power 3 by 2. Now we can put this value in equation 3. So you'll get y bar as minus 1 by 4a square. This y cube is 4a by 3 into x bar minus 2a to the power 3 by 2. So y bar square would be, squaring both sides, this half will cancel out. This would be 1 by 16a to the power 4 square of this, and this is cube. So 4 cube is 64, a cube by 3 cube is 27 into x bar minus 2a whole cube. So y by square would be 4 by 27a x bar minus 2a whole cube. Okay. So after this, there is no x and y. After this, what you have to do? You have to replace y bar by y, and you have to replace x bar by x. So replace y bar by y and x bar by x. So the evolute is y square equals to 4 by 27a into x minus 2a whole cube. This is your evolute regarding the parabola y square equals to 4x. It is a very simple method. First find x bar and y bar, remove x and y. Whatever equation you will get, replace y bar by y and x bar by x. That would be the evolute of the curve. Okay. You can find this by parametric form also. Now what would be the involute of this? If we want to find the involute of this equation. So find involute of the above equation. So how will you find it? Let us see. So you got y square is 4 by 27a x minus 2a whole cube. Okay. And we replaced y bar by y and x bar by x. So you have to do the same thing. That is, replace y by y bar and x by x bar. We know what is x bar here. Here x bar is x minus y1 into 1 plus y1 square by y2, and y bar is y plus 1 plus y1 square by y2. Okay. And let x comma y is the point of involute, is the point of involute. So put these values in place of y bar, you have to put this, in place of x bar you have to put this. If you put this, the differential equation would be y plus 1 plus y1 square by y2 square, that would be 4 by 27a into x minus y1 into 1 plus y1 square by y2 minus 2a whole cube. This differential equation is very difficult to solve, but we understand a family of involutes will be obtained for this evolute, since a differential equation gives a family of curves. We can conclude that there exists a family of involutes corresponding to a single evolute. Okay. Now we can find out this evolute in another way also. So let us see the alternative way. Whatever you feel comfortable, you can apply that method. So let us see alternate way of finding evolute. Let us first see a theorem regarding this. The normal to the involute, the normal to the involute are tangents to its evolute. So a normal of an involute is the tangent of its evolute. So conversely, we can say that the tangents to the evolute are normal to its involute. Oppositely, we can say this also, right? See, this theorem gives the second technique of finding evolutes of a curve. If, let us say, point P travels on a curve gamma, then the variable normals to the curve at P will continuously touch a curve, let us say gamma 1, which is the evolute of the curve gamma. This type of curve gamma 1 is known as envelope of the family of normals. So if f of x comma y comma alpha is 0 gives the family of straight lines where alpha is parameter, then elimination of alpha between the two equation, between the two equations f of x comma y comma alpha 0 and delta f, this is delta f by delta alpha 0, gives the equation of the envelope, gives the equation of the envelope of the family of straight lines f of x comma y comma alpha equals to 0. Okay. Now let us see the same problem, and we will solve the same problem by the second method. So question is, find the equation of the evolute of the parabola y square equals to 4x. Consider evolute as an envelope of family of normals. So we know the parametric form of parabola. This is x equals to 80 square and y equals to 280. This is the parametric form. Now differentiate on both the sides. We will get dx by dt as 280 and dy by dt as 2a. So what would be dy by dx? This would be dy by dt by dx by dt. So this is 2a by 280. This is 1 by t. So what is the equation of normal? Equation of normals at p x comma y, that is at p 80 square comma 280, is, we know the equation of normal, that is y minus y1 equals to minus 1 by m into x minus x1. M is slope. So y minus y1, that is 280, minus 1 by m is dy by dx, that is slope, into x minus x1, that is 80 square. So let us simplify this. Y minus 280, this would be dx by dy. Dy by dx is 1 by t, so dx by dy would be t. This would be minus t into x minus 80 square. So this would be y minus 280 is minus tx plus 80 cube, or we can say tx plus y is 280 plus 80 cube. Okay. Now this is the variable normal, but t is a parameter. So differentiate, we have to take the partial differentiation, right? Because this is partial differentiation of the function. So differentiating partially with respect to t. So let's differentiate with respect to t. So x will be constant. So x dt by dt is 1. Y is constant. 2a dt by dt is 1. And this would be 3a t square. Okay. Now let us say this is our equation 1. This is our equation 2. Now we have to eliminate t from equation 1 and 2. So from this we can say 3a t square is x minus 2a, or t is square root of x minus 2a by 3a. Now put this value here in this equation. So we will get square root of x minus 2a by 3a into x plus y equals to 2a into square root of x minus 2a by 3a plus a into x minus 2a by 3a to the power 3 by 2. So after simplification, you will get y square equals to 4 by 27a into x minus 2a whole cube. Is the same equation we got earlier. So try to simplify this, and you will get this equation, the same equation we got earlier. So we have come to know that there are two methods to find evolutes. Okay. So this theorem, the above theorem just we have learned, is not only gives the alternative way of finding evolute, but it also helps to obtain the result which shows the way of tracing an involute when its corresponding evolute is given. So let us see what is the meaning of this. So let us say gamma 1 be a curve. Let us draw a diagram first. This should be a straight line. Let us say this is the point P. This is B. This is your y-axis. This is your x-axis. This is gamma 1. This is your point Q. This is tangent T. This is also your gamma 1. This point is A. So let us see. So this gamma 1 be a curve. Let us say this gamma 1 be a curve, and A be a fixed point on this gamma 1 curve. Okay. K be an arbitrary position positive number. Let us say K be a arbitrary positive number. B, this B point is a point taken arbitrarily such that mod of AB is that positive number K. This mod of AB is the distance is that arbitrary number K. Then an involute of this curve gamma 1, say gamma, will pass through the point B, and if a tangent of gamma 1 at an arbitrary point, let us say Q, on it cuts at P point, then we can say that mod of QP, that is this distance, is the curvature AQ, this the curvature AQ plus that constant K. Okay. So here AQ curvature is the length of the arc AQ. Okay. Now what is the method of tracing an involute of a curve? So let's see this method of tracing an involute of a curve. So let gamma 1 be a curve. This is the same figure we are considering. Take a fixed point A on gamma 1. Consider any number k which is greater than 0. Take the variable point q. Let us say this is the variable point q on gamma 1 curve, and the tangent of gamma 1 at q. Take a point P on this tangent such that this condition satisfied. Mod of QP is AQ, that is length of the arc AQ plus that constant. As this Q travels on the curve gamma 1, the locus of the point P, the locus of the point, if this Q travels, then tangent will travel. Okay, tangent also travels. If this is here, tangent will travel. If this is here, tangent will travel in this way, right? So this tangent will travel in the curve PB. So as Q travels on gamma 1, the locus of the point P will trace an involute gamma. This will trace. Okay, this tangent will trace this curve. It would be noted that there will exist a point on gamma whose distance from A will be K. That is AB is K. There should be a point on AB, this curve, gamma curve. Thus, for every number k, we will get an involute. So there exists a family of involutes of a curve. These are family of involutes. These are family of involutes. Okay, the family of involutes are drawn as dotted lines. So let us see by one example. Okay, now we will see 2 to 3 questions to understand this topic completely. After that, practice some questions on your own. This chapter is more or less easy. What you have to remember? You have to remember just 4 to 5 formulas and the job is done. So let us see one question. Find the radius of curvature of the parabola y square equals to 4x at its vertex. Hence, find its curvature at that point. So let's see. So for this parabola, the vertex is at origin, right? This is y square equals to 4x format. So vertex is at origin. So this is the given parabola. Now let us differentiate both the sides. So it would be 2y into dy by dx. We are writing it as y1 and this would be 4. So we can say y into y1 is 2 or y1 is 2y. So at 0, 0, y1 would be 2y0, right? So in this manner it is not possible because y1 would be infinite. So you have to go to the alternate formula. Now let us differentiate with respect to y. Here we have differentiate with respect to x. Now let us differentiate y square equals to 4x with respect to y. So this would be 2y 4 into dx by dy, or y would be twice dx by dy. Dx by dy, we can say this is x1. So x1 is y by 2. So at 0, 0, if you put 0 in place of y, x1 would be 0. Okay. Now let us say this is our equation 2. Now differentiating 2 with respect to y again, we'll get 1 twice d2x by dy square. Now d2x by dy square is x2, we can say. So x2 would be 1 by 2. You know the radius of curvature rho, that is 1 plus x1 square to the power 3 by 2 by x2. So at 0, 0, radius of curvature would be, put at 0, 0, x1 is 0, x2 is half. So put the values here. you will get 1 plus 0 to the power 3 by 2 by half. So it would be 2. So what would be the curvature? The curvature is inversely proportional to the radius of curvature. So that would be 1 by 2. Okay. So let us see another question. We'll see 2 more questions and we will wrap up this chapter. Find the radius of curvature of the curve x equals to a cos cube theta and y equals to a sin cube theta at theta equals to pi by 4. So this is in the parametric form. So let us first differentiate this thing with respect to theta. So this would be minus 3a cos square theta sin theta, because first we have to differentiate for powers. So it would be 3 cos square theta, and for cos theta it would be minus sin theta. So that's why minus 3a cos square theta sin theta. And let us differentiate this equation with respect to theta. So dy by d theta would be 3a sin square theta, and for sin theta it would be cos theta. So what is dy by dx? It would be dy by d theta by dx by d theta. So that is 3a sin square theta cos theta by minus 3a cos square theta sin theta. Cancelling all the similar terms, you will get minus sin theta by cos theta, that is minus tan theta. At pi by 4, at theta equals to pi by 4, this is your y1, we can say. So y1 is minus tan pi by 4, that is minus 1. Okay. Now this is your dy by dx. So what would be your d2y by dx2? You are differentiating with respect to x, but here it is theta. So you have to do, we can write this as ddx of dy by dx. So what is dy by dx? That is minus tan theta. So ddx of minus tan theta. So we can write it as dd theta of minus tan theta into d theta by dx. D theta d zero cancel out, this will be the same thing. Differentiation of tan theta is minus x square theta. Minus is already there, so tan theta is x square theta. And d theta by dx. We know dx by d theta, so d theta by dx would be reciprocal of this. So it would be minus minus will cancel out. So it would be sec square theta into 1 by 3a cos square theta sin theta. So it would be 1 by cos sec square theta is 1 by cos square theta, 3a cos to the power 4 theta sin theta. So at theta equals to pi by 4, okay, this y2 would be cos of pi by 4, that is 1 by root 2 to the power 4, and sin of pi by 4 is 1 by root 2. Okay. After simplification, you will get 4 root 2 by 3a. So at theta equals to pi by 4, what is the radius of curvature? It would be 1 plus, we know formula, 1 plus y1 square to the power 3 by 2 by y2. So it would be 1 plus minus 1 square to the power 3 by 2. We know the values y1 and y2, divided by 4 root 2 by 3a. So this would be 3a by 4 root 2 into 2 to the power 3 by 2. This would be root 2 cube. So it would be 2 root 2. Root 2 will cancel out. We will get 3a by 2. Okay, this is the radius of curvature. More or less, remember these type of questions are more or less similar. You have to practice, then you can solve this type of questions. So let us see another question. Find the evolute of the curve this x to the power 2 by 3 plus y to the power 2 by 3 is a to the power 2 by 3. This is asteroid curve. So let us take the parametric form. For this you have to take x equals to a cos cube theta and y equals to a sin cube theta. This is for our convenience. We have taken x and y in this format because cos cube and 1 by 3 will cancel out, cube and 1 by 3 cancel out. That's why we have taken in this format. So let us find out dx by d theta. So it would be 3a cos square theta and differentiation of cos theta is minus sin theta. So it would be minus 3a sin theta cos square theta. And what would be the differentiation of this? So dy by d theta, this would be 3a sin square theta cosine of theta. So what is dy by dx? This would be dy by d theta by dx by d theta. So 3a sin square theta cosine of theta upon minus 3a sin theta cos square theta. This will be minus tan theta. You can solve this question by first method or second method. Okay, you can choose any one of the method. Here I will solve this by first method. You have to try on your own. By the second method, you will and you have to check whether the answer is same or not. So let us find out d2y by dx2. We can write this as ddx of dy by dx. So ddx of minus tan theta, we have just seen how to solve this. dd theta of minus tan theta into d theta by dx. So minus sec square theta into d theta by dx. So we know dx by d theta is this. So d theta by dx will be 1 by this. Minus minus will cancel out. Sec square theta is 1 by cos square theta. So it would be 1 by 3a sin theta cos to the power 4 theta. Okay. Now let us say x bar y bar be the center of curvature. of the curve at x comma y. So we can say, we know that x bar is x minus y1, 1 plus y1 square by y2. So what is x? X is a cos cube theta. A cos cube theta minus, what is your y1? Y1 is minus tan theta. So it would be minus tan theta into 1 plus tan square theta divided by y2 is this thing, 1 by 3a sin theta cos to the power 4 theta. So this would be a cos cube theta plus minus minus plus, it will go in the numerator. Then this would be tan theta into 1 plus tan square theta is x square theta into this whole thing, 3a sin theta cos to the power 4 theta. Okay. Now this is a cos cube theta plus, we can say that this is tan theta is sin theta by cos theta. 1 cos theta will cancel out. Sin theta and sin theta, sin square theta, and sec square theta is 1 by cos square theta. So we can say that this is 3a sin square theta by cos square theta into cos cube theta. So if you cancel this cos square theta with this, you will get cos theta. Ultimately, a cos cube theta plus 3a sin square theta into cos theta. Okay. Now this is a cos cube theta plus 3a. In place of sin square theta, you can write 1 minus cos square theta. 1 minus cos square theta into cos theta. So it would be x bar. X bar would be 3a cos theta. This is minus 3a cos cube theta and a cos cube theta, that is minus 2a cos cube theta. Now we know y1, we know y bar, that is y plus 1 plus y1 square by y2. So y we know a sin cube theta, and we know y1, that is minus tan theta. So y1 square will be 1 plus, this will be tan square theta, and we know y2, this is 1 by 3a sin theta cos to the power 4 theta. So we can say a sin cube theta plus, this is 1 plus tan square theta is sec square theta, and this will come in the numerator with 3a sin theta cos to the power 4 theta. A sin cube theta plus 3a, it will be sin theta by cos square theta, because sec square theta is 1 by cos square theta into cos to the power 4 theta. So if you cancel out, you will get a sin cube theta plus 3a sin theta cos square theta. In place of cos square theta, you can write 1 minus sin square theta. So it would be a sin cube theta plus 3a sin theta into 1 minus sin square theta. So it would be 3a sine theta minus this is 3a sine cube theta, and this is a sine cube theta, so it would be minus 2a sine cube theta. So let us say this is equation number 2, this is equation number 1. Now what we have to do, we have to eliminate theta from 1 and 2. So let's add 1 and 2. So it would be 3a cos theta plus sine theta minus, if you take 2a common, it will be cos cube theta plus sine cube of theta. Now this is a into 3 cos theta plus sine theta minus twice, we have taken a common, you have to apply a cube plus b cube formula, that is a plus b whole cube minus 3ab into a plus b. So this would be a, if you take cos theta plus sine theta common from all the sides, from all of the terms, you will get a cos theta plus sine theta 3 minus 2 cos theta plus sine theta square minus 3 cos theta sine theta. This would be a cos theta plus sine theta into 3 minus, you can say twice, this is sin square theta plus cos square theta, this is 1 minus plus 2 sin theta cos theta minus 3 sin theta cos theta, you will get 1 sin theta cos theta. So this is twice into 1 minus sin theta cos theta. So this would be a cos theta plus sin theta, okay, into 1 plus twice sin theta cos theta. So this would be a plus b whole cube, because we know the formula a plus b into a square plus ab plus b square. Okay, so this would be a into cos theta plus sin theta whole cube, or we can say this is, in place of 1 we can say this is sin square theta plus cos square theta. So then it would be sin square theta plus 2 sin theta cos theta plus cos square theta, then it would be sin theta plus cos theta whole square, and then here we have 1, so cos sin theta plus cos theta whole cube. Or we can say x bar plus y bar to the power 2 by 3 is a to the power 2 by 3, and this is cos theta plus sin theta square. We do both the sides 2 by 3. Now we have to subtract 2 from 1. To do this, you will get x bar minus y bar, that is 3a cos theta minus sin theta minus 2a cos cube theta minus sin cube theta, and x bar minus y bar, the power 2 by 3. This would be a to the power 2 by 3 into cos theta minus sin theta square. You have to proceed in the same manner. You will get this. Here we got cos theta plus sin theta. You will get cos theta minus sin theta here. Okay. Now let us say this is our third equation. This is our fourth equation. So if you add 3 and 4, we will get x bar plus y bar to the power 2 by 3 plus x bar minus y bar to the power 2 by 3, that is a to the power 2 by 3 into 2. Okay. So locus of the center of curvature is the equation of evolute. So you can say the equation of evolute is this. This is the equation of evolute. So see, the processes are almost same. You have to be very careful in finding this type of question. This type of question may be lengthy, but it is coding. Okay. Now practice 5 to 10 questions on your own and the job will be done. So if you like the video, please share with your friends and comment in the next video what chapter you need me to upload. That's all for today. Thank you and have a good day. Take care of yourself.